Okay, let's add the modern period to this so that we can proceed with what we have been doing since the Industrial Revolution. Holocene, one would argue there is clearly an impact of humans on land use and maybe increases in greenhouse gases. In the modern times, we are now considered a forcing, and as we said before, a forcing is when any particular process like volcanoes, solar variability, orbital changes affect the radiative balance at the top of the atmosphere in terms of the short wave coming in and the long wave going out. So as modern human beings, volcanoes do this as well, for example. As modern human beings, we have started taking out CO2 buried as hydrocarbons over long periods and burning it at a rate that we are changing greenhouse gas concentrations and altering the radiative balance, as we will see and we have already seen a couple of times. So let's look at the temperature changes over the Industrial Revolution period. Typically it should go back before 1880, but we always use a baseline where instrumental records become quite reliable. So this is showing the anomalies of global temperature distribution with respect to a base period, which can be anything 1961 to 90, 19th century, 20th century, which just changes the relative magnitude of the anomalies, but doesn't change the story in terms of how we are starting with large places where there are blue colors which are negative, and there are small spots of warm colors which are warmer than the base period. So large parts are colder than the base period, and we will see that as you go through and come up into the 21st century, the anomalies become all reddish yellowish colors with respect to the baseline. So even if you shift the baseline, the basic story doesn't change, that the warming now has become quite ubiquitous and widespread. Okay, so let's see. I have to be able to do this. Why am I not able to do that? Okay. Yeah, okay. So this is jumping in 5-year periods, so it's usually easier to take 5-year running means to look at trends. And you can see by the Second World War we are already beginning to have more yellows and reds, but by the time we hit 1970 or so, the acceleration of warming is fairly obvious, and now you can see there are tremendously large regions of yellow and red colors, and we have discussed a little bit about this region here in the Eastern Pacific. It's very critical whether this is warming or not warming, or whether it's warming less than the West or more than the West, and so on, because remember in the climatology when we looked at El Nino, we said this region is climatologically cold and this region in the West is climatologically warm. So there is a east-west sea surface temperature gradient which creates a pressure gradient, and the winds, which are part of the climatology of trade winds, upwelling, ocean heat uptake, and so on. With global warming, if this region warms less than the West, then that east-west temperature gradient begins to get stronger as a trend, and that means the ocean heat uptake continues, which means the atmospheric warming, which is what we typically call global warming, will be modulated. Okay, there's a lot of detail there that I'm not going into here, but you can look at my other podcasts elsewhere in climate change introduction and so on. And this is called here the polar amplification, because there is ice albedo feedback and water vapor and cloud feedbacks happening in the polar circle. This is warming much faster than the rest of the world. Of course, you have to remember that the mean temperatures here are very cold, so a small warming here is much worse news in terms of atmospheric response, coupled response, extreme rainfall, cyclones, and so on. So tropics warming is bad news for the so-called global south, developing countries, which are very vulnerable to climate change. change and climate disasters, whereas this is bad news, of course, in terms of Arctic ice loss, Greenland melting, glacier loss, and so on. And the Antarctic region is complicated because the Southern Ocean warming would result in a wetter atmosphere and more snowfall on parts of Antarctica. So Antarctic glacier loss is kind of a mixed bag, with some glaciers, especially those that are flowing onto the ocean and creating shelf ice, become very vulnerable to ocean warming from below, even if snowfall is increasing on top. So ice calving, glacier calving, and other instabilities are playing out in Antarctica, but some regions are actually, as you can see here, cooling, and there may be glacier growth there as well. This region, of course, should remind you of the Atlantic meridional overturning circulation. So if we warm the globe as a whole, what happens to the winds and the deep water formation and the Atlantic meridional overturning circulation? It turns out that the Atlantic meridional overturning circulation is weakening, and there are debates about whether it is this part of the Atlantic meridional circulation that is weakening and bringing less heat, or this part that is affected, which is taking out more heat on this side, that is related to human activities. Nonetheless, the high latitude warmings also begin to affect the tropical region, especially droughts and floods over Indian monsoon region, and of course the Middle East and Mediterranean regions here are warming more as well. And the last 5-year period here, the warming comes way down. We can go back and play this again if you want to look at it. Oops, sorry, did it not work? That's not going to work, so I should somehow go back. Okay, here we are. So you can see that we start out with great warming here, which disappears, and then northern hemisphere is different than the southern hemisphere, again because of the land distribution, the climate, Southern Ocean, and the circular motion in this polar circle versus this polar circle, and so on. And you can see that as we get into the 90s, these regions begin to warm more, and more recently the warming has spread down this way. So you have to you can take a box over this region and see how it changes over time, but nonetheless, looking at the other impacts of this global warming. So we are increasing greenhouse gases with fossil fuel burning, land use change, rice paddies, livestock, etc., which are still related to the kind of activities we talked about in the context of the Holocene. And the physics of increasing greenhouse gases is very simple, that you trap more of the outgoing long wave energy in the system, so temperatures begin to warm. The dynamics produce this complicated warming and less warming and cooling patterns that we just looked at, but the glaciers begin to feel the impact. So the glaciers in all these places are losing mass. So there is 400 billion tons of approximate total glacier loss per year since 1994. 400 billion tons. What will that do? As we will see, obviously there will be a sea level rise as the glaciers melt. That water runs off into the ocean, and there is a eustatic sea level rise that is global. And there are specific regions of concern. The glacier melt over Greenland is accelerating, so there is 294 billion metric tons approximate loss per year. There are processes like moulins where top of the glacier melts, the albedo goes down as water ponds form, the water burrows into the glacier, goes all the way to the bottom, creates waterfalls. You can find amazing pictures of it, scary pictures of it on the internet, and then the water at the bottom begins to act as a lubricant to accelerate the sliding of the glaciers down the slopes into the ocean, and so on. So the entire globe is losing glaciers, and the Arctic sea ice is kind of a poster child that's being watched closely and could be one of the first big indicators of human impacts in terms of disappearance of potentially the disappearance of summer sea ice completely, which would open up pathways, shipping routes from the North Atlantic into the North Pacific, and many countries are salivating at the prospect of having huge amounts of buried oil and gas over here. But you can see that the Arctic sea ice trend since 1979 in terms of millions of square kilometer, this is the annual Arctic sea ice minimum, which typically happens in September, and that's bad news. We are heading down here and accelerating. Of course, as we said, this results in sea level rise, global mean, but there will be dynamic patterns as well. So various contributions are estimated from Greenland, Antarctic ice sheets, thermal expansion due to water warming up, and mountain glacier contributions. So that's the tide gauge data, and this is the satellite data which started coming in from 1993 onwards, and you can see both of them are quite in agreement with each other. But bad news again is that there is an acceleration of the global sea level rise, and there are hot spots of accelerating sea level rise, let's say on the US East Coast from North Carolina to Massachusetts or so, northeastern Bay of Bengal, and so on and so forth, for various reasons. Will Stephan and the gang puts together these pictures of the Anthropocene great acceleration, as they call it, looking at socioeconomic trends. Populations have accelerated super exponentially since about the 1950s, but as we said already, fertility rates have dropped and populations are beginning to peak out, even in a country like China, and hopefully soon in India as well. But real GDP has gone up. Extended lifespans, reduced infant mortality, green revolution, etc. are responsible for this as well as for this. So standards of living on average have gone up for a lot of people. Foreign direct investment, which every country wants. Global economic growth is a driver for all these consumption. More and more people live in urban centers, so urban population goes up. Of course, we are very energy intensive creatures with a lifestyle now requiring more and more energy, so primary energy use in exajoules has gone up. Fertilizer consumption, green revolution came mostly with the fertilizer consumption, so that's bad news in terms of greenhouse gas emissions, water quality, air quality. Large dams, people have built more and more dams, and hopefully they are flattening out because people also realize the limitations to them, and they have some bad effects in terms of increasing methane emissions in the stored waters and so on. Water use in thousands of kilometer cube have obviously increased with the population increase and lifestyle increase, where richer people typically consume more water. And paper production accelerating, which leads to deforestation, loss of tree cover, and so on. Motor vehicles gone up. Telecommunications have really ramped up since the cell phone revolution, mobile communication revolution happened. International tourism, improved GDP per capita income come with international tourism. Is that a bad thing? Each generation is known by its explorations, cultural exchanges, exposure to new languages, cultures, foods, etc. So there are advantages. Of course, it also creates employment, but of course it creates the greenhouse gas emissions as well. You can split the socioeconomic trends into organization of economic cooperation and development, richer countries, Brazil, India, China, and Soviet Union, or Brazil, Russia, India, China, and South Africa, the BRICS countries, and others. And as you can imagine, contribution of population has come from BRICS and others. Real GDP increase has come from OECD, and so on with foreign direct investment as well. Urban population increasing in all categories, and fertilizer consumption now peaking out in OECD but increasing in China, India, which have to feed their populations. Large dams mostly came from OECD countries, but China and India, BRICS and others have caught up. Water use, again, everybody is playing the game. Paper production mostly dominated by OECD countries, but BRICS are catching up. Transportation obviously dominated in terms of millions of motor vehicles by OECD countries, but as India and China grow in economy as they want to, they will continue to increase the number of vehicles as well. Telecommunications, again, more recently dominated by China and India. In India, they always say there are more cell phones than toilets, so it indicates how easy it is to have a cell phone, even if you're poor. Earth system trends include, of course, what we already looked at, atmospheric CO2 concentration in ppm from before the Industrial Revolution, coming out of the last glacial maximum, neglecting the contributions of humans that Bill Ruddiman talks about in the previous podcast that we looked at. We have now crossed 420 ppm. This stops at 2010. Nitrous oxide has increased from agricultural and other activities, methane from cattle, rice paddies, and industrial activities. This is more complicated. We don't always understand the rates of change of methane. Stratospheric ozone, not directly related to global warming, but related directly to human activities like refrigerants. There has been continued efforts to replace CFCs with HFCs, which are less harmful to ozone, but they are tremendously bad greenhouse gases. Surface temperature, obviously, the natural variability that used to show ups and downs is almost gone. We just have very rapid warming since the 1970s, as we saw in that animation. Ocean acidification, the hydrogen ion in nanomoles per kilogram is going up, so pH is dropping below the levels we haven't seen in millions of years. We will see that a little bit later on as well. Millions of tons of marine fish captured. Shrimp aquaculture has grown super exponentially. Nitrogen flow into coastal regions have grown exponentially because of fertilizer use in lawns and gardens and other things, and this has serious impact on coastal water quality, harmful algal bloom, species compositions, and so on. Tropical forest loss has had some slowdown in recent years, which is good news, but Amazon is still getting devastated. Domesticated land, some flattening, but obviously we have domesticated more and more land, and terrestrial biosphere degradation has grown over the Industrial Revolution period as well. So let's leave this great acceleration here and then come back and look at some more impacts in terms of where all the additional energy that's being trapped by increased greenhouse gases is going, and then go on to see how modern human and modern climate are interacting and what it means for the future. Okay, let me leave it here.